are taken as a basic unit of rate of change of momentum. Rate of change of momentum is nothing but force, which has unit ml t power minus 2. So this we should express as in terms of basic units: area, speed, and density. A power L, V power M, rho power N. Area L square, velocity Lt power minus 1, and density mass per unit volume. So comparing powers of this is L power 2L plus M minus 3N, T power minus M power L. Comparing like powers, we get N is equal to 1, M is 2, 2L plus 3, M minus 3N is 1. So 2L, M here is 2, N is 1, from here 2L is 2, L is 1. So finally it is A power 1, M value is 2, V square, and rho power N here is 1. So second option. Here it is. Density as per significant figures. Density is mass per unit volume. Mass here is given 1.00 into 10 power 3. Volume is 8.0 meter cube. So here, after a decimal point, zeros are significant. So this has 4 significant digits. Here you have 2 significant digits. While in the multiplication or division, while evaluating density, we'll consider a number which is having minimum number of significance digit. Here one has 2 significant digits, other has 4 significant digits. Minimum will be 2. So once you calculate D, it must have 2 significant digits. So this can't be the answer, right? This can, because here you have 3 significant digits, either third option or fourth option. So here it is 10 cube by 8 will be 125, but it has 3 significant digits. So now, if drop digit is 5, so this I can write it as 12.5 into 10 cube. Still it has 3 significant. We want 2 significant digits. So 12.5 into, 10. I'll write it as 1.25 into 10 square. Still it has 3 significant digits. We should round it off so that it has finally 2 significant digits. So here drop digit is 5, exactly 5, and preceding digit is even. It remains the same. If it is odd, it added. So now which is equal to 1.2 into 10 square kg meter power minus 3. So fourth option is correct. So here in a mixture of ideal gases, the molecules have some mixture of ideal gases. So different ideal gases, different molecular weights. So here it is most probable speed, which is root 2 RT by M. VRMS, root mean square speed, 3 RT by M. And here mean speed, which is equal to root 8 RT by M. These are all molecular weights. Speed depends on molecular weight. So all molecules will not have same speeds. If more is the molecular weight, lesser speed. Less is the molecular weight, more speed. But mean translational kinetic energy is 3 by 2 kT. It depends on only temperature. So it is independent of speed. Molecules have same mean translational kinetic energy. So time period of a artificial satellite is root of gm by r. 2 pi r root r by root g into root. So how it varies with respect to density. Density is mass per unit volume. Mass is volume into density. 2 pi r root g into here root m is nothing but root v into root d. So here this volume is in terms of 4 by 3 pi r cube. So this root r cube is r root r. Finally, it is inversely proportional to density of the earth. Here it is. How many lines are leaving Q1 from the charge Q1? How many lines are terminating at Q2? Here, number of electric field lines going out in a charge is directly proportional to magnitude of charge. Here, so Q1 is directly proportional. How many lines? 1, 2, 3, 6, 7, 8 lines are leaving. Here Q2, how many lines are coming? 3, 4, 5, 6 lines are terminating at Q2. But Q1 by Q2 is proportional to 8 by 6. That is Q1 by Q2 is 4 by 3. Here, when it is positive charge, field lines away from it, negative charge, field lines are towards it. So Q1 by Q2 is minus 4 by 3. When a rod OA is rotating about O with a constant angular speed, here is when rod is rotating about O with a constant angular speed. Angular speed about O means, let us say, somewhere its position, it is theta. So angular velocity calculated about the point. So about B, here OA is 5, OB he given to 0.5. So B will be the center. He is asking angular speed of A with respect to B. Angular speed of A with respect to B means, here you have a property. So this is the chord which subtends theta at the circumference. It subtends to theta at the center. So here, angular velocity at B is 2 d theta by dt. So that is 2 times angular velocity. Angular velocity about O, he given it as 10 radian per second. Angular velocity about B is 20 radians per second. So pendulum is vibrating with an amplitude of 90 degrees. So the direction of acceleration at lowest point. Once it executes SHM, so its equation is A sin omega t plus phi. So phi here is initial phase. Dx by dt we get A cos omega t plus phi. Acceleration is, so it is A omega square minus sin omega t plus phi. This minus indicates acceleration is vertically upward towards this fixed point. So at lowest point, acceleration is upwards. Block A and B are lying on a smooth horizontal table at a constant force. A restoring force, masses of A and B are 2 kg and 3 kg. At some instant, acceleration of B is 25. So in general, string is there, we write tension here. Spring is there, we say restoring force. The role of restoring force is same as role of tension in the string. So 100 minus restoring force is mass of B into acceleration. So restoring force at each and every point will be same. So restoring force will be mass of A into A1. So here it is At some instant of acceleration of B, he given 100 minus restoring force. Mass of B here is 3 kg into its acceleration 25. Restoring force is 25 newtons. So mass of this A is 2 into A1. A1 here is 12.5 meter per second square. So a block weighs 16 kg when placed in one pan, false balance. So what he says, it is somewhere it is balanced. It is one pan. This is the another pan. Let us say at D1 and D2 distances. So when it is placed in left plan, let us say total length is L. So M1 into D1 is M2 into D2. So it weighs so here we don't know what is its true weight. Well, right here it is M into D2. Here he given 16 D1 when placed in one pan. So the same mass is placed in the left plan. Here let us say it is placed here. Then it weighs 4 kg. That is MD1 is 4D2. From these two, dividing one with other, here you get M square is 64. Mass, original mass will be 8 kg. A light of wavelength 200 nanometers is Einstein photoelectric equation. H nu is H nu naught plus kinetic energy maximum. H nu here is Hc by lambda. Hc is 1240 electron volt nanometer. Lambda is 200 nanometers. So it is 6.2 electron volts. Work function we given phi is equal to 2 electron volts. 6.2 is equal to 2 plus kinetic energy maximum. So kinetic energy maximum here is 4.2 electron volts. The spring force constant 300 Newton meter cut into two parts. Total length say L, it is 2x, it is 3x. The force constant of shorter part will be K1 L1 is K2 L2. What we have to remember is spring constant into L is always constant. Here K1 is L1 is 2x, K2 is 3x, which is K into 5x. 2K1 here is 3K2. So he is asking force constant of shorter part. Shorter part means 2x, that is K1 he is asking. So K1 into 2x is K into 5x. 2K1 is 5 into K here is 300. So it is 750 Newton per meter. A mass of 2 kg slides down a quarter circular track of radius 1 meter. So here, if you take this as a reference line, so when mass 2 kg is here, circular track radius he given it as 1 meter, then the energy associated when it is at A, it has only potential energy 2 into G. H is this, uh, that is 20 joules. When it comes to B, it has only kinetic energy at B, that is half mv square. Mass here is 2 kg, velocity given 460 joules. But energy here 20, here 60 means there is a loss due to friction. So that is work done by frictional force is equal to the difference, that is 4 joules. Work done will be minus 4 joules. So height from the surface of the earth. So at a height, acceleration due to gravity changes with respect to distance from the center. As we go away from the surface of the earth, at a distance h from the surface, acceleration due to gravity is this. Now he says value of g is 1 by 4 to the near g is acceleration due to gravity near the surface. At a height h, acceleration due to, which is he said g by 4. G by 1 plus h by r whole square. We get 1 plus h by r whole square is 4. From here 1 plus h by r is 2. H by r is 1. We get height. So at a distance equal to the radius of earth from the surface, the acceleration due to gravity is 1/4. So here a ray of light when it is incident at an angle 60 degrees, this is angle of incidence. It is normal. So ray get deviated, and when it is moving from glass medium to the air, it move away from the normal. This is angle of emergence. It is refractive angle. This is angle of incidence, which is 60 degrees. He given. So here it is. What he given is this. This is the incident ray. And it is the emergent ray. So this part is angle of deviation. Angle of deviation we know I1 plus I2 minus A. This is I1 for us, it is I2. So here deviation he given 30 degrees, incident he given I2, A refracting angle 30 degrees. From here I2 is, it is I plus E minus A. So we get here E value as 0. So to find refractive index using Snell's law, let us apply at P. When ray enter from air medium to glass media, 1 into sine 60 is equal to mu into sine I1. So again, when it leaves glass medium to the air media, mu into sine I2 is equal to sine E. So that E is 0, mu can't be 0, I2 will be 0. So here it is, I1 plus I2, we know that A, so which implies I1 is A. So that is sine 60 is equal to mu into sine A, which is mu sine 30. So mu will be sine 60 by sine 30. Refractive index is √3. Your current I is flowing through a long straight hollow cylinder. So this will be the radius, but he is asking magnetic field at a distance r. Here it is r. He is asking magnetic field at a small r, which is less than. By Ampere's law, integral closed integral B dot net magnetic field is equal to mu naught I. Since it is hollow cylinder, so I inside hollow cylinder I 0. So magnetic field inside at any point r less than r, it will be 0.